All right, we're going to talk about some linear optimization, and what you're going to learn today is you're going to be able to apply linear inequalities into business models. And again, this is like something fairly simple, trying to say, see a pattern, kind of go from there. It looks like it's a lot more than it is, but it gets actually a little bit easier as you kind of see it. So let's look at what we're doing here. Okay, so here's a problem, and I'm going to give you like a set of notes to go with this, so just kind of keep that in mind, how this works and kind of go with the pattern. So the area of a parking lot is 600 square meters. A car requires 6 square meters, a bus requires 30 square meters. The tenant can only handle 60 vehicles. If the car is charged $250 and a bus $750, how many of each should be accepted to maximize income? Okay, so you have to decide here, like, what's your X and what's your Y. And maybe you say, like, here X is number of cars and Y is the bus. Okay, your first constraints are like the inequalities that you're going to make. And no matter what, we have what are called real world constraints, which mean X is always going to be greater than or equal to 0. Y is always going to be greater than or equal to 0. Always. And when this works out, like we're saying here, like X is number of cars and Y is number of buses. Yeah, like that. What number do you put there? I don't know yet. We kind of base it based on what we see with the rest of the constraints. So notice that this says square meters, this says square meters, this says square meters. I would put all those together, like 6x plus 30y is, and you can't go any more than the 600, so it has to be less than or equal to 600. And I'll show you how to work with that constraint. At the same time, the attendant can only handle 60 vehicles, so that means X plus Y has to be less than or equal to 60. Okay? Now, graph constraints, find the vertices. Okay, we'll get to that. The objective function, we want to maximize income. So the objective function is this one. You take the money amounts and you go, okay, the profit will be equal to 250x, because you get 250 per car, plus 750 for a bus. I'm going to erase that so I can write it into a smaller space. All right, so we're saying the profit, it's always profit or cost, P or C, is supposed to be equal to 250, and the dollar amounts will always go to this one. All right, and then we'll try to answer the questions. Now, how do I graph this? Okay, let's look at this. X and Y greater than 0. X greater than 0 is line down here. Y greater than 0 is this right here. So we're saying that's at 0, 0, right here. Okay. What I suggest here is doing like your intercepts. So when you say X plus Y is less than or equal to 60, because you can't have more than 60 cars, then the x-intercept here is 60, the y-intercept here is 60. Okay, just look at it like that. The other one was, say, 6x plus 30y is less than or is equal to 600. Square meters, square meters, square meters. Okay, if you divide the 600 by 6, you get an x-intercept of 100. And if you divide 600 by 30, you get a y-intercept of 20. Okay, what that means is, like, there should be a line that crosses this one at 60, 60. 60 here, 60 here, like that. This one, it should be like at 100 and like at 20 and have something like that. Okay, so what that looks like here, okay, I always use that as my highest intercept as my basis of points here. So like I can go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. I'm going like by ones, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay, I don't have room to go by 5s, so I actually have to go by 10s. 10, 20, okay. So this is going to be, and I'm going to write it here, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, that's as high as I need to go. Same thing over here, 10, 20, 30, 40, 50, 60, 70. I think that's as high as I need to go for those, so like that. Okay, so I'm going to do this one in, let's say, green. I'll do this one in a green, and I'll do this one, the other one, in a orange. Okay, so I'm supposed to cross this one. Like, remember, the x-intercept was 60, the y-intercept was 60. So I'm going to cross that one at 60, 60. So I'll make a straight line that crosses like that. Close enough. Hopefully I'm right on the dot. Okay, the other one I want at 120. Right? Okay, so let me adjust that a little bit. Okay, I'm not exactly sure when I paused the thing, so if I go a little bit more on this, I answered like where the vertices are. What I did was, when I shaded this, usually the shaded area is in, like I said, this little section right in here. And you're trying to identify those points, like where they cross, that connects that shaded area. Okay, that shaded area usually happens like in that bottom corner area. Is there examples where, well, yes, and we'll get to that. But you can see here, based on these two, you can kind of see, like, I have a point at 0, 0, a vertex at 0, 20, another one at 60, 0, and another one at 50, 10. Okay, so that's kind of like how that works. And you're going to plug these numbers into this function to see which one gives you the highest answer. 0, 0 is not going to give you the highest answer, so we'll cross that out. 250 times 0 plus 750 times 20 is going to give you an answer of, well, that's 0. That's going to be 150. Okay, and so then we'll go to the next one. It's 250 times 60 plus 750 times 0 gives you an answer of, that's 120. I think that's 150 also. And then the last one is 250 times 50 plus 750 times 10. And that gives you an answer of, that's 75 plus, let's see, 1 second. And that gives you an answer of 200. Okay, so obviously what answers here is that they make maximum profit of $200 when they go for 50 cars and 10 bus spaces. So you can kind of see how that works and kind of go from there. I'll go over more examples in class. I don't want to go too long on this, but this is just an introduction for you to see how it works and how we're going to, say, do these. And just like I said last time, the more often you do these, the easier these problems will get. Anyways, that's it for today. If you have any questions, feel free to ask. And let's say, give you all a magic word for those of you who hopefully listen to this. Magic word will be Astros. Got to show that to me before when I'm checking notes. All right? Thank you.